Well, hello. We're going to look at a little example today where you're going to try and see if the method I describe is biased or not. And if so, can you identify the type of bias? You might remember from past class we talked about, I think it was about 8 different kinds of bias. And maybe this will be an example of one of them. So kind of watch carefully and replay the video if you need to. So this is what I call a reservation problem. You happen to own 5 small cottages that sit along the beach in Marin. Each summer, you rent out the cottages. A cottage can be rented anywhere from 1 to 10 days. These happen to be very popular cottages. Each day of the summer, you have someone staying in each room. In other words, never a vacancy. Upon reviewing your past rental records, you see that your rental distribution is fairly uniform with a common frequency of 10%. In other words, we have various lengths of stay anywhere from 1 to 10 days, and about 10% of our customers pick each one of these lengths of stay, and you kind of see a little graph right here of that. So the average length of stay, well, if you just add up the numbers 1 through 10 and divide by 10, you get an average of about 5.5, which looks like it's right in the middle. So on average, people are renting for 5.5 days. So a friend suggests that instead of going through all of your records, which we would call a census, you could have found a good estimate of the average length of stay by sampling. She suggests the following method. Randomly pick a 20-day window during the summer. Then randomly select one day during that 20-day period and note the rental period for each customer who's currently staying in one of your cottages. And then average the length of stay for these 5 customers. So for example, let's say you pick day 14 and you go stop by the cottages and you see each person who's staying and how long they're staying for. So let's say in cottage A it's a 4-day stay, cottage B is a 6-day stay, etc. So if you just kind of take the customers who are there on day 14 and you average their length of stay, you get about 6 days, which seems pretty good because remember the average is 5.5 days. So this seems like a pretty good method and actually seems very simple. You just got to pick one day, go and see how long the people are staying and just average that, and it seems to give you a pretty good estimate. So it's very simple. But the question is this a biased or unbiased method? So right now just take a moment and ask yourself whether or not this method seems like it's going to be a pretty accurate and reliable method, or is it going to be one that's going to be biased? So let's go ahead and look at this in a little more detail. I'm going to close this window. So what I've done here is I have to first of all kind of build this like 20-day window, and I have to assume that people kind of, are just kind of randomly coming in. So what I've created here is a little spreadsheet that's going to help give me random numbers from 1 through 10. And I'm going to go ahead and pretend like I'm booking my cottages for the summer. I need to get an idea what a 20-day window looks like. So I'm going to go through to here. I'm going to type in customer 1, and this tells me, okay, that customer was a 1-day rental period. So I'm going to put them in cottage A for just 1 day. And then I'll put customer number 2, and that person wants a 6-day stay. So I'm going to put customer 2 in cottage B for 6 days. 1, 2, 3, 4, 5, 6. So I'm just going to take bookings here. I'm going to go to the next one. My customer number 3 is on a 9-day stay. So I'm going to put them in cottage C for 9 days. 1, 2, 3, 4, 5, 6, 7, 8, 9. And so I just kind of continue in this manner, and at any point in time you kind of see where I'm going. Feel free to fast forward the video. Customer 4 is on a 5-day stay. 3, 4, 5. And my next customer, customer 5, is on a 1-day stay. Okay, so now I'm going to go to customer number 6. And that person on an 8-day stay. So I want to look and see where's my earliest available. Okay, so right now cottage A and E will come open the earliest. I'll put that person in cottage E. I'm going to put them on an 8-day stay. So 1, 2, 3, 4, 5, 6, 7, 8. And I'll just kind of continue going until I've got all my rooms booked through day 20. So again, anytime you feel like you're ready to move ahead in the video, go right ahead. Okay, so my earliest cottage is here, so I'm going to put them on a 9-day reservation. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so now my earliest is going to be cottage D, so I'm going to put my next customer in cottage D for a 7-day rental. 1, 2, 3, 4, 5, 6, 7. So in this situation, it's basically customers aren't picking their days. It's kind of, they're going to take the first available cottage, because these, like I say, these are very, very popular cottages. Okay, next customer's on a 9-day stay, so I'm going to put them on a 9-day stay. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm just going to continue on until I've got every cottage booked through day 20. Customer number 10. 7-day stay. Okay, so here's my earliest cottage, so I'm going to put them on a 7-day stay. 1, 2, 3, 4, 5, 6, 7. And so on. Customer 11. 2-day stay. Customer 12. 7-day stay. 1, 2, 3, 4, 5, 6, 7. Customer 13. 5-day stay. Okay. 2, 3, 2-day stay. Okay, so this room's going to come open again. 4-day stay. Nine-day stay. So for some of these, we're going to end up going past day 20, and that's all right. We're almost there. We just got to get these last 2 cottages booked. So 19, got a 2-day stay. That'll go right here, 2 days. And customer 20. 6-day stay. So 1, 2, 3, 4, 5, 6. So right now everything's been booked through day 20. I think one more customer ought to. So a 10-day stay. 2, 3. Okay, so I've got everything, as you can kind of see here, all booked out all the way through day number 20. Okay, so then what I now do is I'm going to use, okay, so the computer has randomly picked a day among the first 20 days, day number 4. So I'm going to focus in on day number 4, and I'm going to see how long people are staying. So this customer right here is on a 1, 2, 3, 4, 5, 6, 7. That person's on an 8-day reservation, 8-day stay. In cottage B, this person is in the midst of they're on a 6-day stay. In cottage C, 1, 2, 3, 4, 5, 6, 7, 8, 9 day stay. In cottage D, this person's on a 1, 2, 3, 4, 5-day stay. And then let's see, cottage E, this person's on a 1, 2, 3, 4, 5, 6. This person's also on a 9-day stay. And so now I go ahead and add up those numbers. Let's see, 14, 23, 28, 37, I believe. Let me double check that. 14, 23, 28, 37. And then divide that by 5 customers. And I end up getting, let's see, 5 goes into 35 7 times. And then I believe it's 0.4. So that's what I get for the average length of stay, 7.4 days, which is a little higher than the 5.5 average that I thought about before. So I went ahead and had a number of students go through and do this same process of creating a 20-day window and then picking a random day and then recording for me their sample average. And so I'm now going to open up another spreadsheet showing you the results of that process. So I had a whole bunch of students share their average. And this is the graph of what we got. Okay, here are the various averages. So 4 point somethings, 5 point something, 6 point something, 7s, and 8s. Now remember, the group average is 5.5. Okay, notice how most of our samples came in over 5.5. This suggests that there might be some bias in the method. Anytime you have samples that are either most of them are over predicting or most of them are under predicting the parameter, in this case 5.5, it's an indication that you might have some bias in the process. In fact, even on average, all my students got an average of 6.38. We came in general higher than the 5.5 average. So something seems off here because we're not accurately predicting the 5.5 average. So now what remains for you to decide is, okay, what kind of bias is this? And this will be the first problem you're going to need to answer on the assignment. So record what kind of bias you think it is and why you think it's that kind of bias. Thanks for watching.